Hi, my name is Sochil Menjivar, and for this class's final project, I decided to build a plant monitoring system. The idea for this came from owning a hot pepper plant that I bought over the summer. We were still mostly in lockdown at this point, so I was able to spend a lot of time learning how to care for my plant. Different plants have different needs, like for instance, my plant needs a lot of sun as well as constant watering. Other plants may not need so much water or sun, so it really depends on what plant you're taking care of. The idea behind this project is to build a small-scale plant monitoring system that would measure things like temperature, the amount of light, and the moisture of the soil. All of these values would be measured in real time, and all of those sensors would be connected to the microcontroller we are using for this course. The external components consist of a soil moisture sensor probe, a light sensor, and a temperature sensor. These components will take environmental measurements, then pass them to the microprocessor, where the data will then be processed and displayed to the TerraTerm terminal. So as we can see here, this is the system architecture for my plant monitoring system. I have the onboard buttons, SW1 and SW2, as well as the red, blue, and green LED, enabled and connected to GPIO port F. I also have the external sensors connected to GPIO port E over here, which is also connected to the ADC modules, which then takes the sensor readings and converts them to voltages. So once the program interprets these voltages into usable data, this gets displayed through UART to the TerraTerm terminal. So for design and implementation, on the right, we have the picture of the final build of my system. We have the microprocessor here, which is connected to my laptop as a power source. This then gives power to the external sensors that are connected on the breadboard. This is the soil moisture probe, and this is the probe itself that you stick into the soil. And then these are hard to see, but we have the temperature sensor here and the photoresistor over here. Okay, so here we have the flowcharts that implement some of the modules in the program. Here we have main function, which basically initializes all of the necessary modules such as ADC, UART, and the GPIO port functions. We have the GPIO port F interrupt flowchart here. And this basically cycles through the options that lets the user pick which data they want from which sensor. And depending on which one is pressed, it'll cycle through the options in either direction. This interrupt also toggles the LED depending on which option is selected. It does some calculations and it also displays the data to the terminal. And then here we have the ADC interrupts, and each flowchart is associated with each of the external sensor. This one is the temperature, this one is the light sensor, and this one is the soil moisture probe. So one of the main parts of my program is the user interface. And the way I enable the user to take control of the program is through the use of the onboard buttons on the microcontroller. By using the buttons, the user can select what sensor to retrieve the data from. The onboard LEDs of the microcontroller are also programmed to indicate which option you select. So for example, if I wanted to measure the temperature, I could use either buttons SW1 or SW2 to go through the options until I get to temperature. When the temperature option is selected, the blue LED will light up on the microcontroller. The data for temperature will also be displayed on TerraTerm at the same time. So to test the system, I did a few trial runs first using soil samples without any plants in them, then eventually to a few actual indoor and outdoor plants. All of the sensors were tested at the same time to see how well the system was able to do, how to perform, and how consistent the data would be. For the first experiment with soil samples, I used 3 samples in total. The first was soil with no water and was completely dry. The second was with a little bit of water and therefore had some moisture. The third sample had a lot of water in it and was completely muddy. The soil sensors seemed to test well with these samples and were pretty accurate. The light sensor also worked well and detected slight changes in light. The temperature sensor seemed to work as it should, although the readings seemed to be all over the place and did not agree with the other thermometers I used to cross-check the temperature. And then I had similar results when testing the system on actual plants. The soil moisture and light sensors seemed to accurately reflect environmental changes, but the temperature readings kept fluctuating between inaccurate values. So the results of one trial run can be seen here in this screenshot. And this screenshot is from a TerraTerm output. And it basically shows that I cycled through all of the options and sensors. The first one being the soil moisture sensor, which indicates here that the soil was completely dry. Then the next option was the temperature, and it's indicating here that it was 12 degrees Celsius. And the last option was the light sensor, and it's basically just saying that the area was fully lit. So even though the temperature shows 12 degrees Celsius, the actual temperature was probably about 5 degrees warmer. So although all of the sensors were able to be interfaced with the microcontroller and functioned as they should, some of the data are noticeably inaccurate. So the discussion for the results I got, I had some issues with building the system as well as testing it. One of the issues being the inconsistent readings, especially with the temperature sensor, either displaying temperatures that were warmer or colder than the actual temperature.